Hello, my dear students. Hope everybody have written the 10th class English exam well. Now your next exam is science. So today I want to give full clarity on carbon and its compounds. Let us enter into our topic. Hope everybody know about carbon. Do you all remember what is the atomic number of carbon? You can type your answer. What is the atomic number of carbon? Complete chemistry will be depending on atomic number, number of electrons, number of valence electrons. So you need to know about it. Yes, correct. Some of you have already answered. What is the atomic number of carbon? Six. So what is the electronic configuration then? Electronic configuration 2 and 4. 2 comma 4. That means in K shell we will be having 2 electrons and in L shell we will be having 4 electrons. So here outermost shell is L and the number of electrons in its outermost shell is 4. That means how many valence electrons are there? The valence electrons of carbon. Number of valence electrons. Valence electrons of carbon 4. When number of valence electrons are 4, valency is 4. So this is what main basic information we have to know about carbon. So number of valence electrons are 4. So generally already you have listened about metals and non-metals. There you have seen if any atom is having 1 electron or 2 electron or 3 electrons in outermost shell, they will be ready to lose these electrons. 1 electron, 2 electron, 3 electron. They will be ready to lose these electrons and they form cations. By losing electrons, they form cations. Why do they lose electrons? Because they want stability like noble gases. They want 8 electrons in their outermost shell. So if 1 electron, 2 electron, 3 electrons are extra, more than 8 electrons, they will be ready to lose them. So by losing those 1, 2, 3 electrons, they form cations. Similarly, some atoms will have 5, 6, 7 also. For example, nitrogen and chlorine will be having 5, 6, 7. Nitrogen, oxygen, chlorine will be having 5, 6, 7 electrons. When they have 5, 6, 7 electrons, they will be ready to gain electrons. They will not be losing electrons, but they will be ready to gain electrons and they can form anions. But whereas carbon is having 4 electrons, so it will not be ready to lose electrons or it will not be ready to gain electrons. There is one very important question, that why carbon will not form cation or anion. What is the reason? Carbon will not form cation or anion because it is not ready to lose 4 electrons, or it cannot lose 4 electrons, because to lose 4 electrons, to separate these 4 electrons from the carbon atom, we need a lot of energy. So it cannot lose the 4 electrons. At the same time, it cannot gain 4 electrons because there will be only 6 protons inside. So holding 6 protons, 6 electrons and 4 more extra electrons, total 10 electrons along with 4 protons, it will be difficult to hold. So what carbon will not form C4 plus or C4 minus. Carbon does not form cation, that is C4 plus, or anion. It will not lose or it will not gain, it will not form any ion. So how do carbon get, how carbon will get octet configuration, 8 electrons in its outermost shell. So carbon will follow another method to get octet configuration, that is by sharing of electrons. It will not be losing electrons or it will not gain electrons, but carbon share electrons. By sharing electrons, carbon gets octet configuration. Hope you understood. This is one very important point. It will not be ready to lose or ready to gain, or it will not form C4 plus or C4 minus. Hope up to here clear it is. Then after this we'll be having how carbon will get this octet configuration. Just now I told by sharing of electrons carbon will get octet configuration. So here not only carbon, some other atoms also, like by sharing electrons they get octet configuration. The bond, the chemical bond by sharing of electrons, bond formed by sharing of electrons will be called as covalent bond. So carbon forms covalent bonds, and the compounds formed by covalent bond will be called as covalent compounds. We have examples of covalent compounds. I told you just now, covalent compounds are the compounds formed by covalent bonds. How covalent bond will be formed? By sharing of electrons. Example, we are having HCl is a covalent bond. All these we will discuss. I am telling you some examples. CH4, H2O, CO2, NH3. All these are what? Covalent compounds. All these compounds will be formed by forming covalent bonds between atoms. So now here one more very important topic or question that you may get is, what are covalent compounds and what are the properties of covalent compounds? What are the properties of covalent compounds? What are covalent compounds? Compounds formed by sharing of electrons, or compounds formed by covalent bonds. By formation of covalent bonds will be called as covalent compounds. Generally here, what are the important points about the covalent compounds? Covalent compounds are having low melting and boiling point. First point is what? These will be having low melting and boiling points. Why these will be having low melting and boiling points? Because their intermolecular forces are very less comparatively ionic compounds. Low melting and boiling points. This is one property. Why they will be having low melting, low boiling points? Because intermolecular forces are very weak. It is easy to break those bonds. So melting point and boiling point are very low. Next, they are poor conductors of electricity. Poor conductors of electricity. Why? Because there are no positive or negative ions formed in covalent compounds, or there are no electrons, free electrons for conduction of electricity. So they are poor conductors of electricity. Next, one more point, they are soluble in polar compounds like kerosene and petrol, but not in water. Water is a polar non-polar compound. So here what they are these compounds. Are soluble in polar compounds, polar solutions such as kerosene and petrol. So up to here, hope you all understood. So what we discussed, what is carbon, what is carbon's atomic number, what is electronic configuration, how many valence electrons are there, why it will not form positive ion or negative ion, how covalent compounds will be formed, covalent bond will be formed, what are the main properties of covalent compounds. Next important topic in carbon and its compounds is how to draw electron dot structures of covalent compounds. I told you just now some of the examples of covalent compounds. In that, now we are going to discuss how to draw the electron dot structure. Let us see how H2 will form. Electron dot structure of H2. What is the atomic number of hydrogen? Atomic number of hydrogen 1. That means every hydrogen atom will have only one valence electron. Then one first hydrogen will be having one electron and second hydrogen will be having one electron. This is what before bond formation. After that, what happens? Each hydrogen will give one electron. Each hydrogen will give one electron. Then after bond formation, these two electrons, one is given by one electron, another is given by one more hydrogen atom. One electron will be given by one hydrogen and another will be given by another hydrogen. These two electrons will be mutually shared by both the hydrogen atoms. Then like this hydrogen molecule will be formed. H2 molecule will be formed. H2 molecule is formed. In this, how many pairs of electrons are shared? One pair of electrons are shared. We can also represent like this. There is a single covalent bond. Means what? One pair of electrons are shared between hydrogen and hydrogen. This is about electron dot structure of H2. Similarly, O2. What is the atomic number of oxygen? Atomic number of oxygen. Atomic number of oxygen is 8 and its electronic configuration is 2, 6. By this we should understand each oxygen atom will have 6 electrons in its outermost shell. So but it want 8 electrons in its outermost shell. So what happens? One oxygen will give, this one already we have seen, I have done one video, but because it is very important topic, I am telling you again. So like this, first oxygen will give 2 electrons and this is second oxygen. This is what before bond formation. After covalent bond is formed, it will be there like this. First oxygen, this is second oxygen. What happens? Each oxygen will give 2 electrons. So between oxygen and oxygen, how many bonds will be shared? Between oxygen and oxygen, 2 pairs of electrons will be shared. 2 pairs of electrons will be shared. So this is what formation of O2 molecule. O2 molecule, and it can be represented like this. O double bond O. So this is what formation of oxygen molecule. So similarly, so here one double bond is there between oxygen and oxygen. Now let us discuss about nitrogen into formation of N2 molecule. So here what, again you need to know what is electronic configuration of nitrogen. Nitrogen atomic number. Atomic number is atomic number is 7. Electronic configuration is 2, 5. So each nitrogen will have 5 electrons in its outermost shell. First nitrogen will have 5 electrons. Second nitrogen will have 5 electrons in outermost shell, in their outermost shell. So this is what before formation of bond. Then after formation of molecule, it will be there like this. First nitrogen 2 electrons, second nitrogen here 2 electrons. First nitrogen will give 3 electrons. Second nitrogen also contributes 3 electrons. So there will be triple bond between nitrogen and nitrogen. This is what nitrogen molecule or N2 molecule. So it can also be represented like this. nitrogen nitrogen triple bond. So this is what formation of nitrogen molecule. So like this, one pair of electrons or two pair of electrons or three pair of electrons also can be shared between atom and one atom and another atom. Now these all are what? Same type of atoms are there in all these three examples. Now let us see one more, HCl, hydrochloric acid. How covalent bond will be formed between hydrogen and chlorine? Let us see here. So here what? Hydrogen will be having only one electron in its outermost shell, but chlorine will be having 7 electrons. Hope everybody know the electronic configuration of chlorine. Okay, let us write electronic configuration of chlorine first so that you will understand. Chlorine electronic configuration. Chlorine atomic number is 17 and electronic configuration is 2, 8, 7. So there will be 7 electrons in there. Sin 7 electrons in its outermost shell. Hydrogen already we know. In hydrogen we have only 1 electron in its outermost shell. Whereas in chlorine we will be having 7 electrons. 1, 2, 3, 4, 5, 6 here, 7. So what happens? First hydrogen will give 1 electron and chlorine will give 1 electron. This one pair of electrons will be shared between hydrogen and chlorine. Here hydrogen, this 1 electron is already contributed. In chlorine, 1, 2, 3, 4, 5, 6, here 1 electron is given. Like this, how many covalent bonds are present between hydrogen and chlorine here? Only one pair of electrons. You can also represent it like this. HCl, one single covalent bond is present between hydrogen and chlorine. Like this, HCl molecule is formed. So hope everybody understood how to draw the electron dot structures of covalent compounds. Here only few I have shown you. If you want more, I have done one video only on electron dot structures. You can see that video, you can watch video to understand better about this electron dot structures. Now let us see what is next important topic in carbon and its compounds. Next important topic is hydrocarbons. What are hydrocarbons? Do you all have idea about hydrocarbons? What are the different types of hydrocarbons we have? There are two types of hydrocarbons. Hydrocarbons are of two types. One is saturated hydrocarbons and another unsaturated hydrocarbons. Saturated hydrocarbons, unsaturated hydrocarbons. When do we say hydrocarbons are saturated? If there is one single bond between carbon and carbon atoms, if there is one single bond between carbon and carbon atoms, we call them as saturated hydrocarbons, and saturated hydrocarbons are also called alkanes. Alkanes are saturated hydrocarbons. In all the alkanes, we will be having one single covalent bond, a single covalent bond between carbon and carbon atoms. In unsaturated, we will be having two types. One is alkenes and one more is what? Alkynes. Both are unsaturated only. Hope everybody know about it. One is alkenes and other is alkynes. What about alkenes? How many carbon bonds, how many covalent bonds will be there between carbon and carbon in alkenes? You can type your answer if you know it. How many covalent bonds are there between carbon and carbon atoms? Double bond. If there is a double bond between carbon and carbon atom, we call those hydrocarbons as alkenes. What about alkynes? If you have triple bond between carbon and carbon, we call them alkynes. So how many types of hydrocarbons? First, only two types, saturated and unsaturated hydrocarbons. If there is a single covalent bond between carbon and carbon atom, we call them saturated hydrocarbons, and they are alkanes. In unsaturated, again we have two types, that is alkenes and alkynes. If there is double bond between carbon and carbon, we call it as alkene. If there is triple bond between carbon and carbon, we call it as alkynes. So here, after this, it is very important to remember the general formula of alkanes, alkenes, alkynes, which tells us how many carbon atoms are there and how many hydrogen atoms are there in each type. So now general formula, let us see what is the general formula. General formula of alkanes. Do you know anyone alkanes general formula? That is CN H2N plus 2. CN H2N plus 2. What it means? If you have one carbon, there will be two carbons and plus 2. Means what? 2 more than the double. Number of hydrogens will be 2 more than the double of carbon atoms. Suppose if you have 2 carbons here, what happens? Double is 4 and plus 2. 4 plus 2, 6 hydrogen atoms will be there. For example, 10 carbons we have, double is 20, 20 plus 2, 22 hydrogens will be there. So like that, number of carbons and number of hydrogen, just by remembering general formula, you can say how many carbons are there, how many hydrogens are there in alkanes. Similarly, alkenes is what? CN H2N. Means what? Here number of hydrogens will be exactly double the number of carbons. In alkenes, number of hydrogens are exactly double the number of carbons. For example, I have here 12 hydrogens. Then how many carbons should be there in this? If there are 12 hydrogens, how many carbons should be there in that particular alkene? Exactly half. If 12 hydrogens are there, there must be 6 carbons. So like that, if you know hydrogens, you can write carbons. If you know carbons, you can also write hydrogen. That is about alkenes. And then alkynes. Alkynes, what happens? Number of hydrogens will be less. That is 2n minus 2. So that is what? It is 2 hydrogens less than the double. Here 2 hydrogens more than the double. Here exactly double. Here 2 less than the double. So try to remember these general formulas of alkanes, alkenes, alkynes. Now let us write some general formulas to get idea. For example, if you have one carbon atom, how many hydrogen should be there? 2 into 1, 2, 2 plus 2, 4. CH4. Then can we write here in the same way? C1 if I took, CH2 will come. Is it possible? It is not possible in alkenes and in alkynes also. Why? Because we'll discuss again when we draw the structures of these alkanes, alkenes, alkynes. That also we will discuss how to draw the structures later. First we will discuss how to write the molecular formulas. So this is possible, methane is possible, but you remember there is no methane or there is no methane. Why it is, we will discuss later, but you remember it. Methane is there, methane and methane are not there, you try to remember it. So what is the first member of alkane? Methane. I did not tell you about the sounds. Hope everybody remember, if there is one carbon, only one carbon, what we give the name? Meth. Suffix will be meth. If there are two carbons, suffix will be eth, ethane, ethene, ethyne. If there are three carbons, prefix will be prop. Name will be prop. If there are 4 carbons, name will start with but. If there are 5 carbons, Its name will start with pent. Hope everybody know it. 6 carbons hex, 7 carbons hep, 8 carbons oct, like that. So now methane is present, but methane and methane is not present. You try to remember. Now later, if there are 2 carbons, how many hydrogen should be there? 2 into 2, 4, 4 plus 2, 6 hydrogen should be there. This is what? Ethene. 2 carbons are there. Eth should be, with eth we have to start. So it is eth and it is alkane. So it is ethane. This is what? The molecular formula of ethane. Now ethene. What will be ethene? If 2 carbons are there, exactly double hydrogen should be there. So C2H4. This is what? Ethene. Then what is ethyne? C2H2 into 2, 4. 4 minus 2. 4 minus 2 is again 2. So it is C2H2. Hope you understood how to write molecular formulas of alkenes, alkanes and alkynes based on general formulas. So this is about ethene. Similarly, if you write propane, what happens? C3 double is 6, 6 plus 2, 8. Here exactly double, C3H6 propene. Here 3, 2 less than the double, 2 less than the double, double is 6, 2 should be subtracted, so 4, C3H4. So this is what? Propine. Propane, propene, propine. Similarly, if you want bute, C4H, Hite is exactly double, 2 more you should add, so C4H10. Then next, C4 exactly double, so C4H8. This is what? Butane. Butane, butine, butene. Next butine. C4H, 2 less than the double. Double is 8, 2 less than the double is 6. C4H6. So like this, we can write the molecular formulas of alkenes, alkanes, alkenes and alkynes. Hope you understood how to write the molecular formulas. Now let us see how to draw the structures of these. Very quickly, we will discuss how to draw the structures of this. And here, what is the bond capacity of carbon? We need to remember. The bond capacity of carbon is 4. Means what? It can form 4 covalent bonds. For example, if you want to draw the structure of CH4, 1 carbon in middle and 4 hydrogens, 4 single bonds. This is what? Methane. It is alkane with 1 carbon, so methane. I told you methane and methane is not possible because if you want a double bond between carbon and carbon, you need, okay, if you take, we need to have a double bond between carbon and carbon. So it is not possible because we will be having only single carbon in meth. When you have meth, only 1 carbon will be there, and you cannot have double bond with hydrogen because hydrogen capacity is only 1. So like this, for double bond and triple bond it is not possible because hydrogen capacity is only 1. Between carbon and carbon, if you want double bond, at least 2 carbons should be required. So 2 carbons are not there in meth. When you write meth, only 1 carbon will be there. So this is about methane. Methane. Now ethane. Ethane. C2H6. Ethane. Ethane means what? How many carbons? 2 carbons will be there between carbon and carbon, a single covalent bond. But on first carbon we can have 3 hydrogens. On second carbon also we can have 3 hydrogens. This is what? Structure of ethane, where on first carbon you have 4 covalent bonds, 1, 2, 3, 4. On second carbon also you will be having 4 covalent bonds. So this is what? Ethane. Now we can also draw ethene. When we want ethene, between carbon and carbon you should have a double bond. Now on the first carbon, first carbon is having already 2 bonds, 2 covalent bonds are over. So it can have only 2 more covalent bonds. So what? Those two more covalent bonds will be there between carbon and hydrogen like this. Even on the second also same. This is what structure of ethene. So if you observe here, first carbon is having 4 covalent bonds, here double bond, and here single bond, here single bond, 4 covalent bonds. Similarly, second carbon is also having 4 covalent bonds. So this is what structure of ethene. There is a double bond between carbon and carbon. Coming to ethyne, we should have triple bond between carbon and carbon. So triple bond between carbon and carbon, and because already first carbon is having 3 covalent bonds, it can have only one more covalent bond, that is here, and here also this one only one covalent bonds. That's why here the structure molecular formula will be C2H6, 2 carbons and 6 hydrogens. Here C2H4, exactly double hydrogens, and here 2 carbons, 2 less than the double of number of carbons here, hydrogen, that is C2H2. Hope you understood these structures. Based on these structures, we can also draw propene, propane, propane, butane, butane. Everywhere, first you take the carbon and carbon. Between carbon and carbon, if it is alkene, you need to draw one double bond. Let us see propene also, so you may understand more better. Propene, at one propene we will draw, and then we go to the next topic. Hope everybody video, voice and video clear. You all are understanding. So next one, let us see propane structure, propene structure, and propyne structure. So here propane, because it is a saturated hydrocarbon, let us write the molecular formulas so that structures we can write easily. This is what C3H6 plus 2, 6 plus 2 is 8, C3H8. This is exactly double, so C3H6. This is what less than, 2 less than the double, so C3H4. So we have to draw the structures of these. Now here what, because between carbon and carbon you must have only one single covalent bond, so you can draw like this: first carbon, second carbon, third carbon. So here everywhere we must have only single covalent bond between carbon and carbon. Now on first carbon you can have 3 hydrogens. Okay, on second carbon we will be having 2 hydrogens. On the third carbon we will be having 3 hydrogens. Over. Now if you observe, every carbon is satisfied. Every carbon is having 4 covalent bonds. Even second carbon also 4 covalent bonds. Third carbon also 4 covalent bonds. And it is as per your molecular formula, C3H6, H8. So this is what structure of propane. Now similarly, if you come to propane, how can we draw the propane structure? 3 carbons first you draw, and now between carbon and carbon there should be a double bond first. So I am having here one double bond between carbon and carbon, first carbon and second carbon. Now if you observe, first carbon already 2 covalent bonds are over, so only 2 more covalent bonds. So those 2 more covalent bonds will be hydrogen and hydrogen. Now first carbon is satisfied already. Now going to second carbon, here one single covalent bond we must draw between carbon and carbon. So if you observe second carbon, here left side already double bond is there, right side already single bond is there. Already 3 bonds are over. So only one bond is left over. That is what? Hydrogen. Here one hydrogen. Now coming to last carbon there is only one single covalent bond. So 3 more must be there. So here one covalent bond, here one covalent bond, here one covalent bond. Now if you observe here, for last carbon also we have 4 bonds. So observe first carbon 4 bonds, second carbon 4 bonds, third carbon also 4 bonds. If you count the hydrogens, you will be having 6 hydrogens, 3 carbons. So this is what structure of propene. If you want to draw the structure of propyne, again what we have to do, we have to follow in the same way. What? 3 carbons we must draw, first carbon, second carbon, third carbon. Now between first carbon and second carbon we must have a triple bond because it is alkyne propyne. Then on the first carbon only three bonds are over, only one bond is left. That one bond we have to draw between hydrogen and carbon. Now if you come to second carbon, on second carbon already three bonds are over left side, and we need to draw one bond between carbon and carbon. So already four bonds are over, no hydrogens will be there on the second carbon in propyne because left side three bonds, between carbon and carbon one bond. So already four bonds are over, no hydrogen we will draw between on second carbon. Now coming to third carbon, on third carbon we have drawn one covalent bond is over, so three more are left. So three more covalent bonds will be between hydrogen and carbon like this. So this is what structure of propyne. So in the similar way, this is what structure of propyne. Similar way you can also draw the structures of butane, butene, butine, pentane, pentene, pentyne. Same procedure we have to follow. If it is alkane, there must be single bond between carbon and carbon. If it is alkene, you should draw double bond between first and second carbons. If it is alkyne, you must draw triple bond, and then you see that whether the carbon is having four covalent bonds around it or not. If it is not, you can draw hydrogen between carbon and hydrogen. You have to draw the single bond. Hope you understood all these structures of saturated and unsaturated hydrocarbons. This is one important area, and here one more question also you may get. What kind of question? How many covalent bonds are there? How many covalent bonds are there in C3H8? So here you need to know how to draw the structure. Once you know the structure, in that structure you can count the bonds, how many are there, and you can answer. Can you answer anybody how many bonds are there in propane? How many covalent bonds are there in propane? How many covalent bonds are there in propane? Can you answer? Yes, you can count and answer because once you know structure how to draw, you can count and answer. Here 1, 2, 3, 4 already, and here 5, 6, 7, 8, 9, 10. Similarly here single bonds are there, double bonds are there. How many double bonds are there? One double bond is there. And how many single covalent bonds are there? One double bond. And how many single covalent bonds? 1, 2, 3, 4, 5, 6, 7. One single covalent bond, or 7 single covalent bonds and one double bond. 7 single bonds, one double bond. And here one triple bond, and how many single bonds? 1, 2, 3, 4, 5. So like this, after you are drawing the structure, how many single bonds are there, how many double bonds are there, or triple bonds are there, you can count and answer. This is one type. And another type, one more important question here. You know, if you write all the alkanes molecular formula, it is CH4 and then C2H6 and then C3H8 and then C4H10. If you observe all these molecular formulae, there will be a difference of one carbon and two hydrogens. There will be a difference of one carbon and two hydrogens. That is CH2 will be different. One carbon and two hydrogens will be different from each successive member of the alkane, or each successive member of alkene, or each successive member of alkyne, whatever you take, alkane or alkene or alkyne, what difference will be there? One carbon and two hydrogens. CH2 will be the difference. And sometimes they may ask you, what is the difference of mass? What is the difference of mass between any two successive members? Difference of mass will be one carbon will be having 12 and one hydrogen, two hydrogens are there, two hydrogens are having 12 plus 2 total 14 grams. It will be difference of mass between any two successive members. If they ask you mass difference, that is 14. If they ask you this molecular formula difference, that is CH2. Try to remember. All these will be having in that group, alkanes or alkynes in that group, they all will be having same chemical properties but different properties, different physical properties. Same chemical properties but different physical properties. Why difficult physical properties? Because there is a difference in mass number. When there is a difference in mass number, you will be having different physical properties. These structures are also different, so you will be having different physical properties but same chemical properties. That is about structures. That is about hydrocarbons, different type of hydrocarbons, alkanes, alkenes, alkynes. What is their general formula? How to write the molecular formula? How to draw the structures. Now next we have about functional groups. Because you are at the end of the academic year, hope you all know what different types of functional groups and what are their symbols. First one, we have halogen group. If you have these symbols, Cl or chlorine or bromine, halides are attached or halides are displaced. If halides are displacing hydrogens in any alkane or in any hydrocarbon, one hydrogen is replaced by chlorine or bromine or any halide, we call it as halogen group, and its name will be given as a prefix. How? Suppose if it is methane, we write it as chloromethane, chloroethane, chloropropane, like that. Similarly, if it is bromine, then we write it as bromoethane, bromopropane, bromobutane, like that. So this is what first one is halogen group. If in any homologous series one hydrogen is replaced by chlorine or bromine, then we name it as halogen group. And in that halogen group, how name will be given? That chlorine or bromine, whatever you are attaching, according to that we give it as a prefix to that name, chloromethane or bromomethane or chloroethane, chloropropane, like that. So that is what first functional group, halogen group. Second functional group, we have alcohol group. Alcohol group. What is the symbol for alcohol group? OH. If OH is attached or if one hydrogen is replaced by OH, then we call it as alcohol group. And here before, for these two we will give prefix chloro, bromo, like that. But when you have alcohol like this, we write it as suffix. Its name will be given as suffix, like methanol, propanol, OL will be added at last. So suffix OL will be attached at the last of the name, methanol, propanol, butanol, okay, pentanol, like that. So here what is the suffix that is going to be added? OL will be added for alcohol groups. Try to know. And the symbol is what? OH will be attached in the place of hydrogen. Here chlorine or bromine will be attached in the place of hydrogen. This is about alcohol group. Next we have aldehyde group. Aldehyde group. Hope you know about it. Aldehyde group. In aldehyde group, what is the symbol we have? Can anyone tell me what should be attached at last? What symbol should be attached at last? If it is aldehyde, what symbol should be attached at last? If it is aldehyde, we must replace hydrogen by CHO. If CHO is added at last, it is aldehyde group, and we add AL as suffix, like methanol, ethanol, propanol. Here I am writing one example, each one. Chloromethane. Chloromethane. How its structure will be? Like CH. If it is methane, one more hydrogen will be there, but instead of hydrogen we will be having chlorine. And that is what? Chloromethane. Then here ethanol. Let us draw ethanol. name will be there like this, ethanol. Then ethanol structure, how it will be? Ethane structure you need to know to draw the ethanol structure. Two carbons will be there. So this is one hydrogen, this is one hydrogen. One more hydrogen should be there. In that hydrogen, instead of hydrogen, we'll write OH. So this is what? Ethanol structure. Similarly, if you want to draw the ethanol or propanol, then what? Two carbons, hydrogens, as it is as ethane. But here what? Already here we wrote CHO. Here one H, here double bond O. So this is what? Instead of hydrogen, we have brought CHO in the place of hydrogen. So this is what? CHO group, aldehyde group. So if it is there like that, we write Al at last. This is about aldehyde group. Next we will be having ketone group. Ketone group. In ketone group, what happens? It is very important to know that when you want to know about ketone, there must be a carbon between other two carbon atoms. So there must be minimum 3 carbon atoms. So ethanol is not possible, methanol is possible, not possible. Ketone group, ketone functional group is possible from propane onwards, because 3 carbon are must, 3 carbons are must. So like this it will be there. This is what a structure of ketone. And if you want one example, and how the sound will come, own sound will come at last. Butanone, propanone, pentanone, pentanone, like that own sound will come like this. So now let us see how propanone will be drawn. So for propanone, how many carbons? 3 carbons should be there. So in the middle carbon we will be having double bond O over, but for other two we will be having hydrogens as it is. This is what structure of propanone, propane, but here instead of one hydrogen up, one hydrogen down, we will be having one double bond and O in the middle. That is what? Propanone. Next we are having carboxylic acid group, carboxylic acid. Carboxylic acid, here the structure will be there like this, COOH. So it is there like this, or COOH, we call it as carboxylic acid group, and the suffix will be added oic acid. Suffix will be oic acid. Let us see one, ethanoic acid. So what? Here also ethanoic means only 2 carbons will be there because it is eth. So here what happens? On the first carbon 3 hydrogens will be there as usual, but on the second carbon here OH, here H, here it is O, double bond O. So what it is? COOH. This should be attached in the place of here at last. So if it is there like this, we call it as COOH, ethanoic acid. This is what ketone, and this is what carboxylic acid structure. So hope you all understood about this. These are also important in your carbon and its compound functional groups and their structures, how to draw. Hope you understood about this. Now we will be having next important topic, that is isomerism. Do you all have idea about isomerism? Isomerism means what? Having same molecular formula but different structure. Compounds which are having, hydrocarbons are compounds which are having same molecular formula but different structures are called isomers, and that process will be called as isomerism. This isomerism we will observe from butane onwards. Let us see one example. How many different ways we can draw the butane? Butane, normal butane, or we also call it as N-butane. 4 carbons will be there as it is, and hydrogens like this. This is what? N-butane. What is the molecular formula? C4H10. This is what, because all are there in straight format, all the carbons are there in straight format, we call it as N-butane or normally butane. And what is another one after this? We can also draw these structures like this, 3 carbons in straight but 1 in down like this. Here also we have 4 carbons but in a different manner. So if you draw hydrogens now on the first carbon, we can draw 3 hydrogens as usual, but on the second carbon already 3 bonds are over, only 1 bond is left over, 1 more bond is left over. But now at the down we are having again 3 more carbons. On the last carbon again 3 more. So what here it is having different structure compared to first one. So here what we call it? Isobutane. It is what? Isobutane. So for a butane, 2 isomers are possible. One is N-butane and other is isobutane. So like this we can draw isomers of butane. Now similarly let us discuss about the isomers of pentane. This is about butane. If you see pentane, how many carbons will be there in pentane? Again 5 carbons. 1, 2, 3, 4, 5 carbons in pentane. Similarly again like before only, here 1 hydrogen, here 1 hydrogen, 3 hydrogens, but on every next carbon 2 hydrogens. This is what? Pentane or N-pentane, because all carbons are in straight format. N-pentane. Now same, what is the molecular formula here? C5H12. C5H12 is the molecular formula. Here with same molecular formula we can also draw one more structure. Let us see what is that another structure. Here 1 carbon, 4 carbons as it is in straight line, but 1 carbon down. So here what happens? Structure will become like this. Here on first carbon 3 hydrogens as it is. On the second carbon here hydrogen, but here on the down carbon again we can draw 3 hydrogens. On the third carbon again only 2 hydrogens. On the last carbon 3 hydrogens. Here also if you observe, you will be having 5 carbons and 12 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the molecular formula will be same, but structure of the compound is same. So here what we call it? It is isopentane. This is isopentane. Now one more also it is possible for pentanes, that is in this way. Only 3 carbons in the straight manner. On the middle carbon 1 carbon up and 1 carbon down. So here what happens? We cannot draw hydrogens on middle carbon. Only this end carbons we have to draw the hydrogens. Here 1, here how many hydrogens? 3 hydrogens. Similarly here also 3 hydrogens. Here again 3 hydrogens. On the last carbon also you will be having 3 hydrogens in this manner. So this is what? Again you will be having 5 carbons and 12 hydrogens. So this is also same molecular formula but different structure. So we call it as neopentane. This is the structure of neopentane. So hope you understood how to draw the isomers. So if you take all the carbons in straight line, we get one type. One carbon down on the second carbon, we get one type. In this here in butane only two types are possible, but in pentane we are having three types. One carbon down, again one more when you come, one carbon down, one carbon up. If you take hexane, we get few more extra. So like this, we will be having molecular formulas, same molecular formulas and different structures. We call them isomers, and the process will be called as isomerism. And these are some isomers of butane and pentane. Along with this, we also have some cyclic structures. Cyclic structures. These are also important. Here I have seen one important question, that is how to draw cyclic hexane. Cyclic hexane. Because it is hexane, it is a saturated hydrocarbon, and let us see how to draw this saturated hydrocarbon. We will be having 6 carbons in hexagonal format like this. Okay, after that, between every carbon and carbon already we have 2 bonds. Every carbon, if you see, already 2 bonds are there. Now for every carbon we need 2 more bonds. So what? Here one hydrogen and one more hydrogen, 2 hydrogens. On each carbon we require 2 more hydrogens. So this is what structure of cyclohexane. Hope you understood how to draw the structure of cyclohexane. This is what structure of cyclohexane. One more also we have, that is benzene. The formula is what? Cyclohexane formula is, how many carbons are there in this? 6 carbons are there, so C6. And how many hydrogens are there in this? 12 hydrogens are there. 12 hydrogens are there. So if you observe the molecular formula, it is not satisfying that alkane's general formula, CnH2n plus 2. It is exactly double, that like alkenes we have. But do you have any double bond between carbon and carbon? No. Because its cyclic structure, it is possible to have 6 carbons and 12 hydrogens with single bond. So this is what speciality of cyclic hexane. It is a saturated hydrocarbon and cyclic structure. One more we have benzene. This is also important structure you need to know. The molecular formula is C6H6 only, C6H6. Now if you see how to draw this, you will be having again 6 carbons like before, 1, 2, hexagonal form, 3, 4, 5, 6. Like this hexagonal format, we will be having 6 carbons. After that, this one carbon, if you see, will be having double bond. Alternatively, we have to take the double bond. It is not a saturated hydrocarbon. Alternatively, we will be having double bonds between carbon and carbon. So one double bond, again leave it. The middle one, that is single bond, again leave it, single bond. Next one is double bond. Alternatively, you have to take the double bonds like this. Now after that, we have to draw the hydrogens according to the carbon capacity. Now first carbon, this carbon, if you see, this side 1, this side 2, only one hydrogen we need, so that hydrogen we draw here. Second one also, here to here 1, only one hydrogen we need. Third one also, again on every carbon we need only one hydrogen, because already there are 3 bonds on either of the side. So over. This is what structure of benzene. Hope you understood about how isomers, structures of like N-butane, isobutane, N-pentane, isopentane, neopentane, then cyclic hexane, benzene. Got clear idea about these? Hope you got clear idea about this. Now let us discuss about next important topic. Very important, next important topic. Here it is what IUPAC naming. How to name the compound based on its structure. Here it is also very important. Sometimes name will be given, you have to draw the structure. Sometimes structure will be given, you have to write the name. Here what you need to know, we need to know functional groups. Based on functional group, what suffix or prefix should be added. Before that, what process we have to follow. First you have to count the number of carbons in the long straight chain of the structure. So what, in that how many number of carbons are there in the straight chain, you have to count. Depends on number of carbons, we give the name to the compound. We already discussed, if there is one carbon, meth. If there is two carbon, if there are two carbons, eth. If there are three carbons, prop. If there are four carbons, but. So based on number of carbons, we decide what is the name. So once you count the number of carbons, then you see what functional group is there in that structure. For example, if you see first one, we have one carbon, so meth will come. Actually it is methane, it must be methane, but instead of one hydrogen, chlorine is attached. Chlorine is what? Halogen group. I told you, whenever halogen group is there, its name will be added before, prefix. So what it is, not just methane, it is chloromethane. It is what? Chloromethane. This is the name of the first structure. Second one, you count the number of carbons. We have 1, 2, 3. Can you answer what is the name of the second structure? You have idea? What is the name of the second structure? How many 3 carbons are there? So what should come? And OH we have. So what will be the name? Yeah, correct. Very good, very good. Because 3 carbons are there, we write it as propane. Actually it is propane, but because we have OH, we remove that E at last, E, and actually it is propane, but what we do, this E we remove. Because it is alcohol, we attach OL at last, so it becomes propanol. Your answer is correct. So what we have to write here? Propanol. Now coming to the third one, what functional group is there in this? Comment your answer. What is the functional group in the third one? What is the functional group in the third one? You are writing name directly. Functional group is what? Aldehyde functional group, and there are 2 carbons. Because there are 2 carbons, the sound will be eth, and because it is Al will be added at last. So actually it is ethane. What we do, like before, we cut E, and because it is aldehyde, we write Al at last. So it becomes ethanol. So the name will be ethanol. Correct? Now what is the functional group present in fourth one? Can you answer what functional group is involved in the fourth one? What functional group is involved in the fourth one? Correct? Good. How did you decide? How we decide? Based on this structure. When that structure is there, here based on this structure, here based on this structure. When this structure is there, what I said, it is ketone group, functional group, ketone functional group. And what will be the name here? Because there are 3 carbons, we write it as propane, but functional group ketone is present. So what suffix must be added? E should be removed and ONE should be added. So what it is? Propanone. It must be propanone. What is the name here? Propanone. Because there are 3 carbons. Now coming to this, can you answer what functional group is involved in this? What functional group is there in the 5th one? What is the functional group in the 5th one? Which functional group is there in 5th one? Correct? Functional group is what? Carboxylic acid. Carboxylic acid. Functional group is carboxylic acid. And what will be the name? Because there are 2 carbons. What will be the name there? Because there are 2, it should be ethane. So ethane should be there. But what? Because there is a functional group carboxylic acid, what suffix should be added? What suffix should be added? Oic acid. So it becomes ethanoic acid. Ethanoic acid. Can you answer what is another name of it? This is IUPAC name, ethanoic acid. Can you answer what is the another name of it? Ethanoic acid, correct. What is the another name of it? One more name also we have. This is one of the important carbon compound in our class 10. That is, another name is what? Acetic acid. I don't know whether spelling is correct or not. Acetic acid is the another name of this one, CH3COOH. Ethanoic acid or acetic acid. Okay, that is okay. Now what will be this one? What is the name of this? Can you answer what is the name of the 6th one? What functional group is there in that? What is the functional group involved in this? Alkene. Double bond. Did you observe double bond? Double bond, when double bond is there, even alkene are also alkene and alkyne are also functional groups. So alkene is there. So what we call it, because there are 2, we write its name as ethene. Already we have seen structure I have drawn before. What change is there in this? I have done a mistake in this. So here there must be only 4 bonds about carbon. No, I have drawn 5 hydrogens. Now it is correct. C2H4, ethene. Now it is correct. Ethene. Now coming to this, here what you have here, between carbon and carbon, how many bonds are there? 3 bonds are there. Then the functional group is what? Alkyne. Alkyne functional group. And because there are 3 carbons, what it will be? Propene. Name will be propyne, not propene. Propyne. Hope you understood this. Now coming to last one, again you have chlorines. So it is halogen group, chloro it should come. And how many carbons are there? 4 carbons are there. When 4 carbons are there, what we call it? Bute. So it should be chlorobutane, but you have 2 chlorines. So here it comes one more new method, new process. When you have 2 like this, 2 or more functional group, 2 same functional group or 2 or more different functional groups, then you need to give the numbering on carbons. It is a very big process, IUPAC naming. We'll see one more video, if it is possible, one more video we will make it only on IUPAC naming. But here these are what some important topics for your final exam. 1, 2, 3, 4. We have to give the naming like this, from left to right and right to left also, both we have to give. After you are giving like this, you have to see from which side. For example, from this side if you see 1, 2, 3, 4 on second carbon and third carbon. Even from that side also on second carbon and third carbon you have chlorine. So what you have to write? 2, 3. You have to mention the carbon numbers where the chlorine is attached. So 2, 3. Then you should write one hyphen, that is like that, 2, 3. How many chlorines are there? 2 chlorines are there. When 2 chlorines are there, we have to write dichloro. 2, 3 dichloro. What it is? Because 4 carbons are there, it is butane. So what it is? 2, 3 dichlorobutane is the name of this structure. Hope you understood this, all of you. How to write the name if structure is given. If name is given, how to draw the structure. Both you have to know. It is very important topic here for your final exam. Now with this I will conclude today. One more important topic is there, that is about chemical properties of ethanoic acid, chemical properties of ethanol, and about soap. Those two will discuss in another video because it is already, I think, late. So we'll discuss these topics. After that we will conclude. Very important, these 4 chemical properties of carbon and its compounds. These four are also important. The first one is combustion. Already you know combustion means what? Burning. So here carbon burns in the presence of oxygen. Carbon burns, or any carbon compound burns in the presence of oxygen, and it releases carbon dioxide and water vapor along with heat and light. So that is called, this chemical reaction will be called as combustion. In combustion reaction, what happens? You remember, any hydrocarbon or any carbon compound or hydrocarbon burns in the presence of oxygen, and if you write balanced chemical equation, 2O2, and forms and releases carbon dioxide along with water vapor. So here if you want to balance, here what happens? 2H2. We can check 1 carbon on both the sides, 4 hydrogen on both the sides, 4 oxygens on both the sides. So this is balanced chemical equation. In combustion reaction, what happens? Any carbon compound burns in the presence of oxygen and releases carbon dioxide and water vapor. Along with this, it also releases heat and light. So here what is happening? Heat is released. When heat is released, it is also called as exothermic reaction. So what? This is about combustion. Now coming to oxidation, this is also one of the important reaction. Here what happens? Alcohols will be, hope everybody know what is oxidation first. Do you all remember oxidation in chemical equation and reactions? Chemical equations and reactions you will be having about oxidation and reduction. In oxidation and reduction, what happens? Either oxygen will be added or hydrogen will be removed. Here also in this what happens? Oxygen will be added to alcohol, and after the reaction acid will be formed. From alcohol acid will be formed. For example, we will be having ethanol, C2H5OH, ethanol or ethyl alcohol, in the presence of what? Alkaline KMnO4, potassium permanganate, or one more, acidified K2Cr2O7, that is potassium dichromate. In presence of these two, what happens? It will be converted into CH3COOH. So what happens? Ethanol or ethyl alcohol will be converted into ethanoic acid. This is what? Oxidation. Try to remember. This is combustion and then oxidation. Next, in addition reaction, what happens? Unsaturated hydrocarbons will be converted into saturated. So here you remember as a shortcut like this: burns in presence of oxygen and forms CO2 and water. Here what happens? Alcohol will be converted into acid in the presence of KMnO4 or K2Cr2O7. Here what happens in oxidation, what happens? Unsaturated hydrocarbons will be converted into saturated hydrocarbons. Unsaturated hydrocarbons will be converted into saturated hydrocarbons. For example, we have one unsaturated hydrocarbon like this. This is what? C2H4, alkene, ethene. Then after this what happens? Here we use catalyst. Or palladium. We use these as catalysts and it will be converted H2. One H2 will be added in this process. Now what it happens? This will become saturated. After the reaction, this ethene will become ethane, C2H6. This is what? Addition reaction. We also call it as hydrogenation of oils. Why we call hydrogenation of oil? Because here vegetable oils will be converted by this process. Vegetable oils will be converted into vegetable ghee. This is one important point you have to remember. Here unsaturated will be converted into saturated. You try to remember. Substitution reaction is very simple. Here what happens? Hydrogen in saturated hydrocarbons, hydrogen will be replaced by some other compound like chlorine, and after the reaction what happens? It will be methyl chlorine, chloromethane, CH3Cl and HCl. So one chlorine replaces hydrogen. One hydrogen will be replaced by chlorine in this compound. So this is what? Substitution reaction. Try to remember these four reactions. This is what brief explanation. Most of the topics in carbon and its compounds we completed. Another very important for long answer type, that is chemical properties of ethanol and chemical properties of ethanoic acid, that is esterification, saponification and some other chemical equations are there. I'll try to make one more video if possible. Otherwise you try to revise it, because that is also one very important topic. Soap and detergent, structure of soap and those chemical properties of ethanol and ethanoic acid. Hope this class will help you a lot in your final exam. Share to your friends, tell your friends that we are making videos like this. Subscribe the channel, encourage me. Thank you. Prepare well for your exams.